Hello guys, let's do some questions of isomerism. So in first question, the question is that if we replace HA with D and HB with H, then we will get the compound X. So what will be our structure of compound X? X will be like that. HA is replaced by D and HB is replaced by H. The whole compound remaining will be same, so it will be like that, Br, and here will be CH3 and CS3. That is the compound X. Then if we replace HB with D and HA with H, then we will get the compound Y. So draw the structure of Y. The structure of Y will be like that, HD, here is H and that is Br, then CH3 and CH3. So that is the structure of compound Y. So that is a structure of compound Y and that is a structure of compound X. And we have to tell the relation between X and Y. So these are actually stereoisomers. These are the stereoisomers, but they are not mirror image to each other. That's why they are diastereomers to each other. So these are the diastereomers to each other. In second question, which of the following cyclopentane derivative is optically inactive? We know which compound are optically active. Actually, optically active compound are those compounds which have not any type of element of symmetry. So optically active compound should not have POS, should not have COS. POS means plane of symmetry and COS means center of symmetry. So if we are taking the 5-membered ring, in all these options center of symmetry is absent. So center of symmetry is absent, it means in all these compounds, because if we are taking 5-membered ring, center of symmetry is not present. Now we have to check the POS, plane of symmetry. In first compound, plane of symmetry is absent, so there is no POS, no COS. So we can say it is optically active compound. It is also optically active compound because POS is also absent here. It is also optically active. It is also, and it is also, they are not C. In answer C, let's see. There is plane of symmetry. In option C, there is plane of symmetry. Let's see. We can cut this compound in equal to half by this plane. So there is POS, plane of symmetry is present. That's why our answer will be C, because plane of symmetry is present here. That's why this compound will be optically inactive. Optically inactive. In all these options A, B, D and E, POS and COS both are absent, but only in the option C there is POS, plane of symmetry is present. That's why our answer will be C. C will be optically inactive. Next question is that which is the most stable conformer along 2,3 both axis of compound. So we have to find out most stable conformer. So that is a carbon number 2 and another carbon number 3. So carbon number 2 and carbon number 3. Now first of all we have to decide which group are the largest group. Here is the largest group, that is C2H5. C2H5, and atomic weight of methyl is 15 and atomic weight of fluorine is 18 to 19. 18 or 19. So we can say fluorine is the largest group which is present on second carbon. So we can say the stable conformer will be that conformer on which that ethyl group as well as phenyl group should be at maximum dihedral angle, or we can say they should be at maximum distance. So at 180 dihedral angle between C2H5 and C2H5 and F. So C2H5 and F should be at anti position. That conformer will be the maximum stable conformer. So fluorine and C2H5 both are present at which angle? That is 180 dihedral angle, means anti position to each other. That's why our answer will be B. In next question, assign the double bond configuration to the following. So we can assign the configuration with the help of CIP rule, can in gold pre-log rule. So when we use CIP rule, we can decide that is E, and this configuration is also E using CIP rule. So our answer will be C. Allegra, a common prescription drug with the structure. We have to find out how many stereogenic carbon does Allegra possess. So stereogenic carbon means we have to find out how many chiral carbon are present. Chiral carbon is that carbon which is attached to four different groups. So only one chiral carbon is present here. That is only one chiral carbon. So answer will be A. It is not a chiral carbon because two groups which are attached phenyl, that are same group. This is not also chiral carbon. It is also not a chiral carbon because two methyl group are same. That's why this compound have only one chiral carbon. That is the one chiral carbon. So the answer will be A. Thank you.